Welcome to tutorial 10. Okay. As usual, I will explain the steps, okay, the brief steps for the given questions. So for question 1, it is a simple double integral, okay, y sine of x. Okay, the integrand is y sine of x, and then you have to take the integration from dy first and then dx. Okay, perform the integration with respect to y, we will get this, okay, and then substitute the boundary. We know how to do integration, okay, and then we'll get this, and then after that we will have to integrate it by x, okay, and then we'll get this. Substitute the value. Cosine of 90 is 0, plus cosine of 0 is 1, so the integral is 1 over 2. Okay. You can do dx first and dy, but make sure the boundaries are also exchanged. Okay. And then for the second question, we have to uh, do the same thing again, okay, with different integrand. Okay, we know how to do it. Okay, the integration of a polynomial, multivariable polynomial here. Okay, we'll get this. Okay, with respect to x, integrate this integrand with respect to x. We'll get this. Okay, substitute the boundaries, and then we have this expression, okay, consists only y, and then we have to integrate this with respect to y, and then we substitute the boundaries and we get 88.5. For the third question, okay, it is a plane z equals 4 minus x minus y. We have to integrate z, okay, where x is between 0 and 1 and y is between 2 and 0 and 2. Okay, find the volume. Okay, do the double integral. Okay, you can choose any of the order of the integration, to make sure the boundaries are also matching with the differentials. Okay, and then do the integration. Okay, i I chose dy first. Okay, we get this. Then substitute the boundaries, we'll get 6 minus 2x. Okay, integrate it with respect to x from 0 to 1, and then we have this. Okay, 6x minus x squared. Substitute the boundaries to this and we get 5 units cubed. Okay, and then for the fourth question, this is slightly not that complicated, but it's quite tricky, but if you know how to do it, it's very simple. Okay, here we have to integrate it with respect to y, from 0 to x squared. Okay, we have sine y of x, and then here 1 over 1 over x will become x. Okay, divided by x, okay, we'll get 1. Okay, and then we have this, and then we'll integrate sine of x with respect to x from pi over 2 to pi. We'll get negative cosine x. Substitute the boundaries and we'll get 1. Okay, the answer is 1. And then for 5 is about the Green's theorem. Okay, we have to consider the parabola x squared, and also y, the straight line 2x. Okay, from the right side of the slide we have the graph. Okay, we have to find the intersection, we have to equate both of these. Okay, and we'll get 0 2. Okay, here. Okay, x is 0 and 2, the intersection of x. Okay, intersections of x, and then if we just substitute the boundaries, we already know. Okay, if x is 2 here, okay, 2 times 2 is 4. Okay, or 2 squared is 4, and then substitute here. This is the x boundary, 0 to 2. This is y boundary, x squared. Okay, because it is the most below curve, x squared to 2x. Okay, do this. We know how to do the double integral. If we do it, we'll get 8. Okay, and then next is also Green's theorem. I'm sorry, this is yes, this is basically Green's theorem practically, but this is still under the category of double integral, and this one is the real Green's theorem. Okay, if we have the line integral, we have double integral with respect to area. Okay, partial of q with respect to x minus partial of p with respect to y. And then for this one, this is from exercise 10, and then if we graph the vertices, okay, we have a triangle here. Okay, here x here is we from this we can get the boundary here. Okay, we substitute. Okay, partial of x of this is p, this is q. Okay, this is q. Partial of x of q is 2xy cubed, and then partial of xy with respect to y is x. Okay, and then we substitute it into this. Okay, substitute the boundaries. We do the double integral. We get 2/3. Okay, and then for the final question, okay, this one you have to use polar coordinates. Okay, here I already wrote the polar coordinate here. Okay, r is equal to x squared plus y squared. Okay, the relation. Okay, and then from r for r we have to use boundary 0 to 2. Okay, and then for the angle we need to consider the full cycle, which is 2 pi. Okay, the substitute it will get this. Okay, and then do the integration. This is very I already explained how to do double integral. We get negative 24 pi. And that's it for my tutorial. Thank you for listening.